Welcome to the course 3034 Mechanical Engineering. In this lecture, we will be discussing about two problems related to YouTube manometer. So the first problem, the right limb of a YouTube manometer containing mercury is open to the atmosphere while the left limb is connected to the pipe through which flows a fluid of specific gravity 0.85. The center of the pipe lies 15 cm below the level of mercury in the right limb. If the difference of mercury level in the two limbs is 25 cm, determine the pressure of the fluid of the pipe in Newton per meter square, kilopascal, Newton per mm square and bar. So the figure is given. So in this question, we have to find the pressure of the fluid flowing through this pipe. So this is the pipe through which a fluid of specific gravity 0.85 is flowing. So first we can note down what are the given parameters. So first the properties related to the fluid. So fluid flowing through the pipe, specific gravity is given. Specific gravity of the fluid flowing through this pipe is 0.85. So we can find the density of the fluid. Density of the fluid is determined by multiplying the specific gravity of the fluid with the density of water. So you will get it as 850 kilogram per meter cube. So 850 kilogram per meter cube is the density of fluid. So when a U-tube manometer is connected to this fluid, you can see that the liquid in this pipe pushes the U-tube manometer fluid. The manometric fluid used in this U-tube manometer is mercury. That is, here this fluid is the mercury. Mercury is the manometric fluid. So it pushes the mercury in this tube and we will get a level difference of fluids in the left limb as well as right limb of the manometer. So here this is the left limb and this one is the right limb. You can see that the left limb is connected to the pipe where the pressure is to be measured and the right limb is open to the atmosphere. So from this figure you can see that the level difference between center of the pipe, this point is the center of the pipe, and the mercury level in the right limb is 15 centimeter. And here we are drawing a reference line. This reference line is drawn where there is a separation of fluid in the left limb. So here you can see that up to this reference line, the fluid is having specific gravity 0.85 and below this reference line the fluid is mercury. So this is our reference line. So above the reference line there is a liquid column having 25 centimeter height. So it is mentioned that in the question itself, the center of the pipe lies 15 centimeter below the level of mercury in the right limb, and the difference of mercury level in the two limbs is 25 centimeter. So these two dimensions, 15 centimeter and 25 centimeter, we can see in this figure. Now we have to determine the pressure of the fluid flowing through this pipe. So for finding the pressure of fluid flowing through the pipe, we will consider this reference line and we will equate the pressure above the reference line in the left limb as well as in the right limb. So equating the pressure above reference line equating the pressure above the reference line in left and right limb, we can write P plus, what is this P? P is the pressure of the fluid flowing through this pipe. Now I am denoting this height as H1. That is, so H1 is the height from the center of the pipe, to the reference line. H1 is the height of liquid from the center of the pipe to the reference line. And this liquid is the same liquid that is flowing through the pipe. And this 25 centimeter, that is level difference between the reference line to the top of the right limb, this I am denoting it as H2. And P is the pressure of the fluid flowing through the pipe. In this condition, P plus rho G H1. P plus rho G H1 is the total pressure acting in the left limb above this datum line. So this is our datum line. We are considering the left limb. So in the left limb above the reference line, P plus rho G H1. So I am equating this with the total pressure acting in the right limb above the reference line. So in the right limb, the mercury is the manometric fluid, and here the total pressure acting in the right limb above the reference line is rho Hg G H2. So rho H is the density of mercury. Here we are considering rho as the density of water flowing through this pipe. So what will be the pressure of the fluid inside the pipe? It will be rho Hg into G into H2 minus rho G H1. Here rho is the mercury density of mercury. It is 13,600 kilogram per meter cube. H2 is 25 centimeter, and so from the figure we can see that H1 is equal to H2 minus 15, that is 25 minus 15, which is equal to 10 centimeter. So we are calculating the pressure of fluid flowing through the pipe. P is equal to rho Hg GH2 minus rho G H1 is equal to density of mercury 13,600 into 9.81 into H2. 25 centimeter, we can't take it in centimeter, we are considering it is in meter. 0.25 meter minus 1000 into, sorry, it's not 1000. Density of liquid flowing through the pipe we have already determined. It is 850 into 9.81 into 10 centimeter. H1 is 10 centimeter. It is in meters. It is 0.1 meter. So which is equal to 32,520.15 Newton per meter square. So this is the pressure of the fluid flowing through the pipe. So the pressure of the fluid is 32,520 520.15 Newton per meter square. Now we have to express the fluid pressure in Newton per meter square, kilopascal and Newton per mm square. So we know that 1 Newton per mm meter square is equal to 1 Pascal. So this is same as 32,520.15 Pascal. So in kilopascal it will be 32.52015 kilopascal, and next you have to represent it in Newton per mm square. Okay. So how we will convert this into Newton per mm square? We know that 1 meter is equal to 10 raised to 3 mm. So meter square is equal to 10 raised to 3 whole square, which is equal to 10 raised to 6 mm square. So pressure P is equal to 32520.15 Newton per meter square is equal to 32520.15 Newton per 10 raised to 6 mm square, which is equal to 32520.15 into 10 raised to minus 6 Newton per mm square. Next we have to represent the pressure in bar. So we know that 1 bar is equal to 10 raised to 5 Pascal. So here our pressure is P is equal to 32520.15 Pascal. So pressure in bars will be 32520 32,520 divided by 10 raised to 5, which is equal to 0.3252 bar. So we have calculated the pressure in Newton per meter square. We have converted it into kilopascal and Newton per mm square and bar. Now we can move to the second problem. The second problem is a simple U-tube manometer containing mercury is connected to a pipe in which a fluid of specific gravity 0.8 and having vacuum pressure is flowing. The other end of the manometer is open to atmosphere. Find the vacuum pressure in the pipe if the difference of mercury levels in the two limbs is 40 cm and the height of the fluid in the left limb from the center of the pipe is 15 cm below. Okay. So from the question we can understand that the pressure of the fluid flowing through this pipe, this is our pipe, the pressure of the fluid flowing through this pipe is vacuum pressure. Vacuum pressure means the pressure of the fluid is less than atmospheric pressure. Okay, so we know that generally in a U-tube manometer, if this is the U-tube and if it is not connected to any pipe, the manometric level in the left limb and right limb, left limb as well as right limb, the manometric level in the left limb as well as right limb will be same. So when it connects to a pipe, there will be a level difference in the left limb as well as right limb. So here the U-tube manometer is connected to a pipe in which a fluid having vacuum pressure is flowing. So what will happen when we are connecting the manometer? Here we know that the right limb is open to atmospheric air. So this right limb is open, so atmospheric pressure is acting in the right limb. So here the fluid pressure is less than atmospheric. Here it is vacuum pressure. So what will happen? The atmospheric air pushes the mercury in the right limb and the level of mercury in the left limb will increase. So here the mercury level in the right limb decreases due to the pressure of atmospheric air. Actually it is like this. Initially it was, before connecting to the pipe, the mercury level in the two limbs, left and right limbs, were same. So when it is connected to a U-tube manometer, the mercury level in the right limb lowers, because here the pressure here PATM is acting, atmospheric pressure is acting. Here the pressure in the pipe is vacuum. Here vacuum pressure is there, so atmospheric pressure is greater than this vacuum pressure. So the level of mercury in the right limb decreases and we will get a figure like this. So the level of mercury in the U-tube manometer will look like this in this, as shown in this figure. Now our aim is to find this vacuum pressure. So we already mentioned that vacuum pressure means the pressure will be less than atmospheric pressure. So here also we are considering a datum. So this is the datum line. The datum line is drawn through the mercury level surface in the right limb. Okay. So we know from this figure we can understand that in the left limb there is two fluids and the right limb there is no fluid above the reference line. We are not considering atmospheric pressure. Why? Because atmospheric pressure is acting everywhere. We are considering only gauge pressure. We are not considering atmospheric pressure. So here, considering the fluids above the right limb, above the reference line in the right limb, there is no fluid. Hence the pressure, gauge pressure at this point is 0. And in the left limb above the reference line, there are two fluids. One fluid is the fluid flowing through the pipe and the second fluid is the manometric fluid. The manometric fluid is mercury. Okay. So in this case also we are equating the pressure above the reference line in the left and right limb. So we will get P. P is the pressure of the fluid flowing through the pipe. I am denoting it as PV. Why? Because it is a vacuum pressure, plus, so here there is a dimension 15 centimeter and another dimension 40 centimeter. The height of mercury column in the left limb, this height 40 centimeter, I am marking as H2, and this height, that is from the center of the pipe to the mercury level in the left limb. The height of fluid in the left limb from the center of the pipe is 50 centimeter below. Okay, so from the center of the pipe to the mercury level in the left limb, this height 15 centimeter, I am marking it as H1. So now I am equating the pressures in the left limb as well as right limb. So considering the left limb, the total pressure above the reference line, this is the reference line, and above the, this is the reference line, above the reference line in the left limb, PV, vacuum pressure of the fluid flowing through the pipe, plus rho. Rho is the density of fluid flowing through the pipe, rho GH1, plus there is another fluid, that is mercury, rho Hg into GH2, which is equal to pressure above the right limb in the U tube manometer. So above the reference line there is no fluid, only atmospheric air is there. So the pressure, the gauge pressure is marked as 0. Okay. We have vacuum pressure plus rho G H1 plus rho W G H2 is equal to 0. Or PV, vacuum pressure, is equal to minus of rho Hg GH2 plus rho G H1. So here we have rho Hg, density of mercury is 13,600 into 9.81 into H2. H1, this is H2, 13,600 density of mercury into G, that is 9.81 into 0.40, that is 40 centimeter, we are converting into meters, plus rho, density of fluid flowing through the pipe. Specific gravity is 0.8, so the density will be 800 into G into 0.15. So you will get it as minus 54,000 543.6 Newton per meter square. This minus sign indicates it is vacuum pressure, that is the pressure is less than atmospheric pressure. Okay, in the next lecture we will be discussing about U-tube differential manometers, and we will discuss problems related to U-tube differential manometers.